Welcome to Rges Pre-Algebra Lesson 13B. We're going to cover lessons 4.18 and 4.19. The first lesson has to do with formulas, tables, and graphs. A formula would be a algebraic expression that declares or states a rule. Okay, so an algebraic expression that states a rule. An example of this would be, let's say, the perimeter of a square. If you recall, a square, it's supposed to be a square, that's all right, a little more like a rectangle. It would be the same length on all sides, and perimeter is the measurement around the length. So if I start here and I march up and over and down and around, the perimeter equals 4x. So this is an algebraic expression. What's it equal? It equals the perimeter. And the whole thing together is called my formula for perimeter of a square. So you can create formulas whenever you desire, whenever you want to basically repeat. Okay, I've got a larger one. Let's say this one is 5 on a side. And so the perimeter is 4 times x, or 4 times 5, or 20 square units. But if this one here, I have a 7, my perimeter is still 4x. So the formula itself does not change, but then I'm substituting a new value, in this case the 7. So perimeter in this case would be 4 times 7, or 28 square units. Okay, so that's, and we use formulas all the time, and we create them for our own uses, as well as, for instance, geometric formulas, or lots of different formulas that do not change. Okay, so some are common, some are famous, and some you'll just create. So when we're getting down to 4.18 and the first 4 questions, they're asking you to create formulas. So they're saying apples sell for $1.80 a pound. What's the cost of P pounds? So the cost, C, would equal the how many pounds? How many pounds? What's the variable I'm using for pounds? That would be P, small p. They tell you that in the problem. And of course, it's going to be multiplied by 1.80 for every pound. Now, typically, we write the numerical coefficient in front. Typically, if we have a trailing 0, like here, we don't need it. So to clean that up, a better answer for a formula would be C equals 1.8, writing the numerical part first, P. And so you do go ahead and do the other 3 of those. And then what we do, which is very useful to us, is we create some kind of table or chart. I'm going to talk about Y, and I'm going to talk about P when I'm given the formula P equals 2Y. So here's a new formula, and I can plug in any values I want for Y. 0, they plug in 0 through 15. 1, 2, they didn't have to plug in those, but they decided to, all the way up to 15. And you're supposed to plug in the answers. What would P equal? Well, how do I do that? I use my formula. P equals 2 times Y. Well, if Y is 0, what's 2 times 0? 0. If Y is 1 in the next section, what's 2 times 1? 2. In the next column, if Y is 2, what is 2 times 2? 4. In the next one, if Y is 3, what is 2 times 3? 6. And you keep plugging in. That's what you're going to do for each one of these through 9. Now, when you get to number 10, now we're starting to talk about the graph. So we've talked about the formula. We've talked about tables. You use your formula to get your values for the table. Okay, is the second value typically. Okay, the first value you're just picking, or the book itself has picked values for you. Okay, now what do you do when you get to graphing it? Let's say I have a table and it's 1, 5, 2, 10, 3, 15, 4, 20. And let's say this is my X value and this is my Y value. So on my Y-axis, typically the answer, okay, for the cost or whatever else it represents up above the perimeter, I've got values up to 20. So I'm going to make these equal 5 each, 5, 10, 15, 20. You have to label them so that it's obvious what they equal, and this is my Y-axis or my Y value. My X value here, I'm not really telling you in English what it stands for, okay? I'm going to go 1, 2, 3, 4, 5. Hopefully a little more even than I did. Now, you plot points. First, I go to the X value of 1, and I go up to the Y on the Y-axis, and there's my first point. Then I go over to 2 for my second point. That's a 10. 2 on the X-axis, 10 on the Y-axis up to here, and I put a little point, and I go ahead and circle it for a data point is a good idea. 3, 15, go over to the 3 on the X-axis, go up from the 3 to 15 on the Y-axis. There's my data point. And 4, go up, 5, 10, 15, 20. Oh, a little running out of room. And there's my next point. And if I had chosen a 0 and a 0, I did not choose that, or I didn't see it. So really, technically, I can only draw this line. Whoops. Ooh. Sorry. Whoops. Somehow I moved my plots. Okay, I didn't know you could do that. Well, anyway. Okay, it was kind of like... Bummer. Okay. Okay, my points. I'm going to get this out of the way a little bit too. You got the idea. So my points, again, doing them very quickly here, were that, and that. Okay, so you could technically plot from here to here. If I had 0 in the point, I could include this part. Okay, and so that's what they're asking you to do. Should be fairly straightforward. We'll talk about anything that's confusing. I'll give you one warning. One of these plots will not be a line. So don't be panicky if you come up with something that is not a line. So if you have any further questions, we can talk about it in class. Let's go on to the next lesson, which has to do with signed numbers. Now, signed numbers, you really first want to start thinking about signed numbers by using a number line. All the numbers to the right here are positive. 1, 2, 3, etc. To the left of 0, we have what we call the negative numbers. -1, -2, -3, and they represent kind of a mirror image of the numbers to the right of the 0, including, like if I had 1/2 here, this on the other side of 0, it would be -1/2 right here. Okay, so these would represent mirror images. My writing is not cooperating that much. Okay, so negative could represent less than 0 in temperature. It would represent below 0 with loss of money, rather than, let's say I added $3 into my bank account, I added $7 into my bank account, and I subtracted 5. This could be represented on a number line. If I start with 0, I could add 3, 1, 2, 3, going over to here first. Then I could add 7 more, 1, 2, 3, 4, 5, 6, 7, going all the way over to here. So I would be at 10 now. And then I would go back 5, 1, 2, 3, 4, 5 to here. So notice when I put subtract 5, I'm going to the left on the number line. Whereas if I'm adding, I'm going to the right on a number line. Okay. So they give a little bit further, more detailed explanation of that. But so now we want to understand that, therefore, we use the plus sign in two ways. If we have this expression, what I'm saying is 16 plus, that's an operation, add, a negative 3. So this is using it to show sign or direction, and this is using it to show operation. On a number line, if I start with 0, I would go to the right 16, because 16 is the same as a positive 16, and then I would go to the left 3 to get my final answer. If we have this expression, they're asking you to identify these symbols. We have 3 symbols, 1, 2, 3, these signs. Are they an operation or are they a direction? The first one is a direction, the second one is an operation, and the third one is a direction. What do I mean by that? I would read this, -9 minus, or subtract, +4. See how that works? Let's look at a few more. I could just read this as 6 plus, this is the operation, 8, or I could even read it as saying more than it's looking at, like +6 plus +8 is what I'm thinking there. This is operation, I would say 11 minus 4, knowing that both those numbers are positive. If I said this, this is my operation, and this is whether or not it's a positive or negative number. So I say 6 minus a -2. Very important that you're distinguishing. That's a +5. Okay, how would I read this? This is my operation, so I would read it +8 plus a -8. 5. +5 plus -8. Again, if we said this, how would I read this? This is my operation. I would read this 8 plus a -6. There's my operation. I would read this -9 minus a -4. Okay? So now, having done all that, there's one other thing to instruct you in, and that is this idea of an absolute value. Absolute value are written by 2 long vertical lines and a number written between, or a letter written between. That we would read that the absolute value of n, or the absolute value of -7. Or the absolute value of 3, or the absolute value of 0. Now, what is absolute value? Absolute value represents the distance from 0 on the number line. So if I have 1, 2, 3 sitting here, the absolute value of 3 would be the distance between 0 and 3. So that would equal 3. If I had -4, the absolute value of -4, I would go over to -4 on the number line, and the absolute value of 4 would be the distance between 0 and 3. So that would equal 3. If I had -4, the absolute value of -4, the absolute value of 4 would be the distance between 0 and 3. So that would equal 3. If I had -5, the absolute value of -5 would be the distance between 0 and 3. So that would equal 3. If I had -6, the absolute value of -6 would be the distance between 0 and 3. So that would equal 3. to the left from 0. Okay. And then I would talk about what is this distance. Well, this distance is not negative. I am going from 0 to -4, 1, 2, 3, 4 steps. So the absolute value of -4 is 4. Notice, absolute value is always the positive counterpart. Okay, so let me review that for you one more time in the next page here. If we have the absolute value of 3, that would equal 3. If I have the absolute value of -3, that would equal 3. And if I have the absolute value of 0, that would equal 0. So that should be able to give you down through 20. It says write. Okay. It's just saying write with the correct notation for 21 through 26. If I want to write a -14, I would just do that. If I want to write a +5, let's say, I would either write just a 5 or I would write a +5, like that. So that should clear up all of that. Don't think the rest is a problem for you. Come back with any questions on Monday, and don't forget to study for your quiz.